before we get started, a really fast lesson on the difference between distance and displacement. I'm going to do a traditional physics style problem. I'm going to say bird's eye view. This dot is you. It's a bird's eye view. And you travel east. Let's say we travel east 3 miles. And then you travel north 4 miles. Perfect right triangle there. The distance you traveled is 7 miles. How'd you get that? Yeah, 3 plus 4, right? But that is not your displacement. Displacement is this distance. And the displacement is? So we see the difference between distance and displacement? Okay, so displacement is the net value that you traveled. And I guess I've got to use that word net careful, because a lot of people might think, well, that's 3 plus 4. No, from here to here, that is a distance of 5. So don't worry, this is kind of two-dimensional. We're going to just be talking about one-dimensional motion. So it might be even easier. Cool or not cool? Okay, so check this out. Here we go. We're going to go slow. Example 1. A particle moves along the x-axis, units in centimeters per second. Its initial position is 0. At t equals 0 seconds is 15. So I'm at position 15. The figure shows the graph of the particle's velocity, v of t, in centimeters per second. So I'm going to write v of t here. And this is in, the y-axis is in centimeters per second. And the t-axis is in seconds. The number are the areas of the enclosed region. So this is the area of the region between 0 and A, the area between A and B, and the area between B and C. Are we still okay? All right, so letter A, what are the values? And they tell me. So this is my V of t graph. And I know that integral from 0 to A of V of t, it just means area under the curve, right? So that value, it's from 0 to A, is that area below the x-axis. So I'm going to write what? -4. The area from A to B, that is what? 5. And the area from B to C is? Good. Are we still okay so far? Nothing crazy, right? All right. What is the particle's displacement between 0 and t equals c? So notice they say displacement. So we're going to go slow. So before we even talk about displacement, what does this area mean? So look at the units. Centimeters per second times second is centimeters. So if you're below the x-axis, remember, if velocity is below the x-axis, that means you were moving left. If velocity is positive above the x-axis, that means you were moving right, because I'm either moving left or right. So that 4 means that I moved 4 centimeters to the left. Does that make sense? Okay, so 4 centimeters to the left, and then I went 5 centimeters to the right, and then I went 24 centimeters to the left. Perfect. 23 centimeters to the left, or -23 centimeters. Say one or the other. Don't say -23 centimeters to the left, because that's like a double negative in English, and it's wrong. And they will come wrong. So you can either say 23 centimeters to the left, context questions, or -23 centimeters. Does that make sense to you guys? And I guess I'll put the work here of how we did it. -4 plus 5 minus 24. Nothing crazy. Are we okay? By the way, oh man, I knew I should have added something. I probably should have put, like, give me the symbolic representation of all this. Integral, that's from 0 all the way to where? C of what? V of t equals -23 centimeters. Yay or nay? Perfect. What is the total distance traveled by the particle in the same time period? So now I want total distance. So I went 4 to the left, I went 5 to the right, and I went 24 to the left. What do? Add them up, absolute value, add them all up. So 4, and I like that you said absolute value, miss, plus 5 plus 24. So what's that? Why did you say absolute value? No, I love that answer. But absolute value of what?
Because since we're finding distance, we can't add negatives. I'm really not explaining it.
No, you did it. You did it. You said it perfect, miss.
I did?
Yeah, you said absolute value because you can't add negatives, and that is a negative value. So you did absolute value, right? So if you want to find the distance, can you guys give me an expression that's gonna probably have absolute value, like Guerrero said, sorry. What do you think that expression would look like? Would I put the absolute value on the outside of the integrand or on the inside? Good job. Man, you guys are so smart. Integral absolute value of v of t dt. Notice that the dt is outside the absolute value. Cool or not cool? Equals 33. Oh, yes. Without it, it's an indefinite integral. Yeah, without it, it would be an indefinite integral. It needs to have the zero c. Yeah, good job, miss. Thanks. Cool or not cool, guys? All right, here we go. Give the positions of the particle at A, B, and C. Here's how we're going to do it. Ready? What letter did they use? S? No, X. So it's particle motion on the x-axis. So look what they tell me. Don't they tell me that my initial position was 15? So here's how you're going to write it. I'm going to write my position at A is equal to my initial position, x of 0, plus my displacement between 0 and A. So integral 0 to A of v of t dt. Does that make sense? So let's see, x of A is nothing more than, what was my initial position? 15? 15 plus, and I guess I could also write minus, but plus a negative what? Negative 4, so I'm at position 11. That's the same thing that I'm going to do for B. So I'm going to write x of B equals x of 0 plus integral from 0 all the way to B of v of t dt. So x of B equals 15 plus negative 4 plus 5 was what? 1. So I'm at position 16. And then maybe I should have used 3 different colors because they're all 3 different angles. X of C equals x of 0 plus the displacement from 0 all the way to C of v of t dt. So that equals 15, and my displacement was what? Negative 23? Minus 23, which equals, I guess you can also subtract 24 from the 16. Negative something, what? 16, 17, 19, 20, 1, 2, 3. No, it's negative 7, no? Aren't you at position 16 at B? At B, I'm at 16, so I subtract 24. Oh. Oh, yeah. The 15 is the initial. Yeah. It's the same answer. 16 minus 24 is the same thing. 16 minus 24 is the same thing as 15 minus 23. Right? Yeah, sorry. If I confuse you guys, I'm going to slow down. Don't worry. I'm going to answer you right now. So Guerrero said, why didn't you use 16? And yeah, you could use 16. 16 minus 24 is negative 8. But notice that I wrote 15. And look, why did I write 15? Because 15 was my initial. And notice that I'm going on the whole interval from 0 to C. And that was 23. 15 minus 23 is also negative 8. So it doesn't matter 16 minus 24 or 15 minus 23. It depends on like which one you want to look at. Sorry if I gave you guys hiccups right there. I wasn't looking at my little graph here. So hopefully I didn't say anything wrong. I'll look at the video again to make sure that I said everything right. Estrada, ask me.
Oh, I was just wondering.
Ask.
What? How come we did like 0 to C instead of I thought we would have done like A to B and then B to C.
No, we did. The only reason it's because I wanted to get you guys in the habit of like finding your displacement in the total. Okay, I'll tell you what. Okay, you see how I wrote this expression here? I want you to notice something. I'm going to write it over here. X of c equals x of 0 plus integral 0 to c of v of t dt. So what's the antiderivative of velocity? Position. So this, the antiderivative of that is x of t evaluated from 0 to c. Do you guys see that? Okay, well look at that. Look at this. I'm just going to move this to the left there. And look, x of c minus x of 0, OMG, 0 to c of v of t dt. Look at that. You guys, look at this. Sorry. That means this. This is a position at c. This is a position at 0. If I subtract my position at c minus my position at 0, that is the definition of displacement. OMG, area under the velocity curve is displacement. Do you see how it's all connected? All right, now I could have done, Estrada, I could have, if I wanted to, I could have said x of c is just nothing more than 16. Now notice that I'm using 16, which is the position at b, plus the displacement between b and c of v of t. I could have done that. That's what I was saying. That see that now that's 16 plus a negative 24. But this is the same answer as this. Cool? No, it doesn't. But you see how I have here, I'm about to give you guys formulas. Notice, I want you guys to notice, did I ever give you a formula for position? No, I don't want you to be a robot. We derived it from scratch just by looking at it, and you don't think that's cool? Look, we're about to write a formula. I don't want you to be a robot. I don't want you to be a robot. But a formula for displacement is, here it is. Displacement. This will always work. Displacement is nothing more than the integral from A to B of what? Velocity. So area under the velocity curve will always give me my displacement, which just means the change in distance. Espinosa, we got this? Yeah, because you're going to be an engineer, miss. You're going to see this over and over and over again, I guarantee you. Cool or not cool, guys? All right. All right. Focus, miss. Focus, focus. All right. What about distance? What about distance, Guerrero? From A to B. Yes. Look at that. Yes. Sorry, guys. I got excited there. I saw a cat video once, and the cat was saying yas, but everyone tells me that it was a voiceover. But I'm pretty sure the cat was actually going yas. So, yeah, I think in the cat video it was like, "Do you want a treat?" And the cat was going yas. "Do you want a treat?" Yas. I'll show it to you guys later. It's so funny. All right. All right, guys, focus. I do not want you to be a robot. I want you to see that we derived these equations. We derived it right here. We derived it completely. But if you must be a robot, then you can just remember that. The displacement is always the displacement is always the area under the curve of velocity, A to B, and the distance is the absolute value of velocity from A to B. Cool or not cool? And look, check it out. Just like, and I'll do a side note here. Remember, this by definition is just x of b minus x of a. That's position. That's position. So look, x of b is position, and x of a is position. So x of b is position at b, x of a is position at a, and well, if you take your position at b and your position at a and you subtract them, that's displacement. That's what I meant to say. Yeah, and that's what I was trying to show you up here, how it doesn't matter how you do it. If you're not a robot, you understand it. Look, why did I write it like this? My final position is equal to your initial position plus your displacement. Look, you move that way, and you have the definition of displacement anyways, x of c minus x of 0. Does that make sense? Perfect. So anytime you want, you know what, for good notes, put it here on the side. Anytime you want a position at B, you take your initial position at A, And you're just going to add integral wherever that stops, that starts. So a to b of v of t dt. That's how it's going to look always, always, always. Cool or not cool? Cool. All right, I think you guys are winning. Now we need our calculator. And look, I tried to put an emoji, an awkward emoji, but it's not as cool as the Apple one. So let's see. It says the figure to the right shows the velocity of ds dt, which is v of t equals. So type this in your calculator. So I'm going to take my calculator, and I'm going to go to y equals. Oh, I have a whole bunch of junk in there. Let me erase my junk. How do you reset your calculator, guys? Do you guys know? Second, push the plus symbol, the memory. Go 7, 1, 2. I'll do it again. Second memory, 7, 1, 2. Yeah. So and then you'll see it says RAM cleared. You probably don't have this operating system because this is, or I don't know, what does yours say? 5.8. Okay. So then I need to update mine. Okay. Everyone should have the most up-to-date operating system. I'll check TI just in case there's a newer one. All right, here we go. I'm going to type this into my Y1. Oh, that's my recording software. Y1, Y equals, and I'm going to type x squared. So I go x squared. The x is right next to the alpha. There's no reason for you to push alpha x. So just x and then squared. And then I'm going to go minus, because I think it said minus. Minus, and then I'm going to use a fraction feature, guys. Use a fraction feature. Alpha link or alpha y equals, and then enter, whichever one. I think the alpha link is faster. And then type in 8 over, and I'm going to open up a parenthesis, and then what was it? X plus 1, close parenthesis, and then square. So we're good, right? Now look at the right-hand side. It tells you how the window should look. So here it is. I'm going to go 0 to 5 and negative 10 to 30. So that's exactly what I'm going to make my window. Window, 0 to 5. And I'm going to go by 1. And then negative 10 to 30. And I can see that there's only so many hash marks. And I think they probably did it by 10. So Y scale 10. And I'll push graph. And it should look exactly like that little window there. Maybe not exactly, but it should look like this. Cool or not cool? Cool. All right, here we go. Let's answer their questions. It says, during what time intervals is the particle moving left, moving right? You're moving left whenever the velocity is below the x-axis. You can also say whenever the velocity is negative, because that's probably so I'm going to write that down. I'm going to write moving left when velocity is... you know what? I already wrote it. Velocity is negative. This occurs on interval. Let's see. Definitely, I can put a bracket on 0 because at 0 it's already negative. And then I'm going to put a parenthesis because I hit right there and it looks like it's a little bit bigger than 1. I'm going to figure out what that number is. So take your calculator out. So that number, we call that a 0 because it touches the y-axis and the y value is 0. So there's a command. You see up there where it says calc, that stands for calculate. So push second calc, and these are all the things your calculator can do. I'm going to put number 2, and then it's going to say left bound. So it's asking me where do I want to look between. You can also just type in a number, but it's small enough that I can just scroll. Scroll to the left, enter. You're going to see a little line. And then right bound, go to the right, pass it, and then push enter. Guess. If you have multiple ones, go to the one that you want the best. It needs to say the word 0. Enter. See how it says the word 0? That is the value. 1.2545, at least how many digits after the decimal? At least 3. Rounded or truncated, it doesn't matter. I'm going to put more. 1.2545. Give me one more digit. 4. And I'm going to close it with a parenthesis. You can actually close it with a bracket, but I'm going to close it with a parenthesis because that's when my velocity is negative. Cool or not cool? Cool. Anything crazy? No. Nope, that's it. When am I moving right? It looks like, well, I guess because my interval is only between 0 and 5, from 1.2545 all the way to 5. Moving right when velocity is positive, which occurs, parenthesis, 1.25454, comma, 5 bracket, period. You're stopped for just a moment at 1.25454. Are we winning? Okay. Are we eating? Okay. Is everyone full? Okay, I'll stop. All right. Suppose the initial position of the particle is, so they give me a position. I'm at position 9. What is the particle's position at t equals 1 second? All right. Here we go. Ready? I say my new position at 1 second is nothing more than my initial position at 0 plus the displacement from what to what? Of perfect. Perfecto. S of 0 was 9. And I'm going to go, I guess you don't have to, let's do it anyways. I was going to just say, just get the answer immediately, but okay, here, check it out. You already have it on Y1, right? You do not need to work harder, guys. Look, work smarter. Go to your home screen, second quit. Everyone try this out, guys, because you got to get used to that calculator. So, ready, Espinosa? I push math. Look for integral. What number? 9. What am I gonna put in my integrand here? 0 to 1. And then in here, you could type it again if you wanted to. The best way, you already have it in Y1, no? Call Y1. Alpha trace Y1. Oh, did I? No, it's this one. I just didn't type it. I didn't type it out right. It was initially example 1, but then I moved it because if we would have done this first, we wouldn't be able to derive our formulas. And I wanted you to derive the formulas. We could have derived it still, but this one would have been harder. So sorry, guys. Change it in there. Change it in there. All right, here we go. Enter. 3.666. If you want to turn it into a fraction, math, fraction, enter, and there it is. If you see a repeating decimal, it's a fraction. Negative 11 over 3. So 9 plus negative 11 over 3. Are you sure that it's negative? No, look, the velocity was below the x-axis for the majority, actually for all of it, because this is at t equals 1. So the area is below the x-axis. The velocity is negative, so I'm moving to the left. So I'm going to go in my calculator, 9 plus 11 over 3. You can just put plus, guys, plus 9. Look, boop. 16 over 3 is your new position. Well, yeah, right. 9 times 3 is 27. 27 minus 11. So that's my position at 1. That's a demerit. Who wants the next one? No, YouTube, I'm 100% kidding. I did not write a demerit. Someone yawned. All right, here we go. T equals 5. T equals 5. So help me out, guys. What do I write? I want my position at t equals 5. So I'm going to write S of 5 equals S of 0. That's what they give me. Plus of what? Perfect. Yep. I'm just going to go S of 5, and I'm just going to write the answer. I know that S of 0 is 9, so I'm going to go 9 plus math, number 9 again, 0 all the way to what value? 5. And then I'm going to push alpha trace y1, that's where I have my velocity, and push x, enter. And look, I get a nice pretty number. How do you feel? Okay, now it says, I fixed it on that one, but I didn't fix it on the other one. Find the total distance traveled by the particle in example 2. Don't worry, guys, we're almost done. How do I find the total distance? Guerrero, how do I find the total distance? You told me a little while ago.
Oh, yeah, it's just I don't know
Integral. Yep, 0 to 5, because that's my entire interval. Of what? Absolute value of v of t. Chav, I don't know where the absolute value button is. We're going to show you right now. All right. Here we go. Yeah, ask me, miss. I got the answers. Well, for this, I got the answers. All right, I'm clearing it just so you guys can see. Everyone push the math button. It's like the magic button where you can find all types of stuff. In the top, you have folders, and you're going to go to num. The very first line, do you see where it says ABS? It not stands for analog breaks. It stands for absolute value. Push enter. See? You got absolute value. So this is just to test it. Let's see if it works. -3, enter. It works. Here we go. Math. Number 9. From what to what? 0 to 5. And this is why it's important to type stuff in Y1, because you could easily mess up here with all the symbols and everything. Now how do I put the absolute value in there? Math, num, and it's the very first one. Either enter or push number 1, whatever you want. And there it is. So I now got my absolute value. Now what do I put inside the absolute value? Alpha trace and Y1. There it is. And then I just change that. I make it an X. Enter. And there's my distance traveled. How many digits after the decimal? 3. At least 3. You can always write more. 5868. I'm gonna write the first 4 there. 42.5868. How are we doing on time, guys? Okay, we'll start here for 9th period, and we should be able to finish it. Oh, we just have 2 left. Okay. Thank you, guys. You guys did awesome. Fabulous. Take out your notes that we were working on this morning, and take out your calculators. All right. Let's get back in the game. Don't worry. We're going to finish pretty quick. Excuse me. All right. Here we go. We're going to read all this stuff that it says here. It says, the integral is a natural tool to calculate net change and total accumulation of more quantities than just distance and velocity. Integrals can be used to calculate growth, decay, and as in the next example, consumption. Whenever you want to find cumulative effects of varying rate of change, integrate it. Demand on 3rd edition, page 383. Because I don't remember when I took this quote. I don't remember if I added to it, if I added this last part, or if I wrote it verbatim. But it comes from your textbook, page 383. That's the textbook that we should be using. So yeah. So let me minimize that. Okay, so check it out. Let me see if I say this word correct. I asked a professional yesterday, and she told me to say it a certain way. I'm going to try to say it that way. From 1970 to 1980, the rate of potato consumption in a particular country, so it is some country, is 2.2 plus 1.1 raised to the t power millions of bushels per year. Did I say it right? Bushels. Bushels. Bushels.
No, it's bushels.
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 With t being years since the beginning of 1970. All right, hey, don't worry, guys. We know what we're talking about. How many bushels were consumed from the beginning of 1972 to the end of 1973? Okay, think about, always let, hold on, let's do that really fast. Let's hear this really quick.
Please pardon the interruption. High school track students, if you're participating in today's track, please report to the gym at this time. Thank you.
All right, always let the area under the curve help you out. So think about what this is. Remember, look, this is millions of bushels per year. And look, the t-axis is in years because I'm going from 1972 to 1973. So millions of bushels per year times year is bushels. Cool or not cool? So the area under the curve will tell me how much potatoes they consume, like how many bushels they consume. Does that make sense? So what am I going to do? I'm going to what? Integrate. So here's my integral. What do I use as my lower limit? Do I use 1972? Do I use okay, I'm going to slow down. Look what it says right here. T being years since the beginning of 1970. So 1972 is what T value? 2. And it says the end of 1973. So the end of 1973, how many years have passed? So 2 years have passed. The beginning of 1972, all of 1972, and all of 1973. Right? So 2 to 4, no? Okay, I'll say it again. Look. Year since the beginning of 1970. So the beginning of 1970 is T equals 0. Yes or no? So the beginning of 1971 is T equals 1. Beginning of 1972 is T equals 2. Beginning of 1973 is T equals 3. Notice that I'm saying beginning. Beginning of 1974 is T equals 4. So if they tell me to the end of 1973, isn't that like the very last, towards the very, very end of 19, isn't that a whole year of 1973? So saying the end of 1973 is the same as saying the beginning of 1974, no? Yeah. So there it is, from 2 to 4 of what expression? Yep, there you go. Make sure I put the DT there. Don't worry, in case you think there's ambiguity there will be no ambiguity when it comes to the questions you get on an assessment. Cool or not cool? So if you were to make a mistake on this and put 3, I don't think I would necessarily punish you. I would just note like, well, in context of the question, I believe the end of 1973 means that 2 years have elapsed since the beginning of 1972. Does that make sense, guys? Okay, so there it is. We just use our calculators. So I take my calculator and I go math 9 2 to 4. And I put 2.2 plus 1.1 raised to the power x, and then I put an x. And I got 7.066 millions of bushels. 7.066 millions of that. What is a bushel? Like a kind of like, is it, how big is a bushel? What's the volume? A basket? Okay. So yeah, this 7.066 millions, I can believe that, some country, and that's what they do. They model. They just find a model for a rate. All right, check it out. Let's do this one right here. Don't worry, we're gonna go slow. You guys ready? A pump connected to a generator operates at a varying rate depending on how much power is being drawn from the generator to operate other machinery. This is true. Some machinery does work like that. If it has more current, it goes faster. If it has less current, it goes less fast. All right. A pump connected to the generator operates at a varying rate depending on how much power is being drawn from the generator to operate the other machinery. The rate, it's a rate, guys, gallons per minute at which the pump operates is recorded at 5-minute intervals for 1 hour, as shown in the table to the right. How many gallons were pumped during that hour? So they want to know how many gallons were pumped during that hour. Use dimensional analysis to help you out, just like in chemistry, stoichiometry. All you're doing is using dimensional analysis. Think about what area under the curve means. So if you have gallons per minute and you multiply by minutes, don't you get gallons? Yeah, so there it is. So it wants us to use trapezoidal. Before I continue, does your delta x, which is quote unquote your height for your trapezoid, does it look like they're all 5? So I can use my formula if you want to be fast. Do you guys see that? So my formula, height divided by 2, open parenthesis. And then the very first one, I'm just going to write 58. Plus, and then all the other terms besides the last one have a what in the front? You guys remember? A 2. 2 times 60 plus 2 times 65 plus 2 times 64 plus dot 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 plus 2, and I'm going to go right to the last one. 63 plus 63. That ... means to continue. Are we okay with that? Is anyone tricked or confused? Okay. In symbols, this is what I'm doing here. In symbols, I'm doing this. I'm doing the area under the curve of r of t dt from 0 all the way to 60. And sure enough, r of t is in gallons per minute, or gallons per minute. And your dt is in minutes. And look, you're going to have gallons. Cool or not cool? Be very careful. Let's go ahead and take our calculator. And just be very careful. Let's see. 5 divided by 2. You know what? I'm going to use this. Alpha trace 5 over 2. Parenthesis and I already forgot. Yeah, someone read them to me. Hold on, 58 plus what? 2 times 60 plus 2 times 65, 2 times 64, 2 times 58, 58 plus 2 times 57 plus 2 times 55 plus 2 times 55 plus 2 times 59 plus 2 times 60 plus 2 times 60 again plus 2 times 63 plus another 2, 63, and then 63. Oh.
Wait, no.
Oh, did I put too many? Yeah, like that. Close. Bam. Oh, let me turn that into a decimal. If you want to force your calculator to give you a decimal, actually, I can just type it in again. 71. Oh, it's math 2? Math 2. Look at you guys. 3582.5. 3582.5 gallons. How do we feel? Did today's lesson make sense? Okay.